In this video, we're going to learn about the calculation of formal charge. Formal charge is going to be a tool that we utilize in chemistry to look at the placement of electrons on the right atoms in a Lewis structure. So, when it comes to this, formal charge is given by the following equation. Formal charge equals the number of valence electrons for an atom minus the number of bonds that it has minus the number of lone pairs of electrons in that atom. So we can observe that in the left side of the slide, we have the three Lewis structures that can be drawn for the compound that is known as cyanate. In each one of these Lewis structures, we see the formal charges for the atoms present in that molecule in red circles. So I'm going to take specifically the first Lewis structure to illustrate how the equation can be utilized and where the zero for the oxygen, the zero for the carbon, and the -1 for the nitrogen came from. So I'm going to redraw that Lewis structure. Oxygen has two lone pairs, a double bond to carbon. The carbon has a double bond to nitrogen, and nitrogen also has a lone pair. So at first, let me do the calculation for oxygen. I'm going to determine the number of valence electrons in oxygen, which is going to be 6 because oxygen lives in group 6A. Next, oxygen has specifically two bonds, this one and this one. So I'm going to take 6 minus 2. Lastly, I'm going to look at the number of lone pair electrons. So what that means is that I'm going to count every single dot around oxygen. So when it comes to this, oxygen has 1, 2, 3, 4. It has 4 lone pair electrons present. When I do 6 minus 2 minus 4, that's where the value of 0 came from. Let me now do carbon. When it comes to carbon, carbon lives in group 4A, so it has 4 valence electrons. We can see that when it comes to carbon, in terms of bonds, it has 1, 2, 3, 4 bonds. Minus 4. Minus the number of lone pair electrons around carbon. There is none, so that is 0. So when I solve for my equation, 4 minus 4 minus 0, that equals 0. Let's do the one for nitrogen. When it comes to nitrogen, let's understand that nitrogen specifically has 5 valence electrons because it lives in group 5A. So we write the value of 5 minus the number of bonds. Nitrogen has 1, 2 bonds. So there's 2 bonds here. And then the minus the number of lone pair electrons, which means how many dots are around nitrogen. Nitrogen has 1, 2, 3, 4. Minus 4. So when we do 5 minus 2, that's 3. 3 minus 4, that is -1. So that's why the values that we saw here of 0, 0, -1, this is where they come from. Let's now practice by doing a problem in which we're going to build the Lewis structure and then determine the formal charges for the atoms in that molecule. As you can see in this practice problem, we're going to draw the Lewis structure for the polyatomic ion CO3 - 2, meaning carbonate. And we're going to determine the formal charges of all the atoms in the molecule. So when it comes to the Lewis structure for carbonate, we're going to write its chemical formula, CO3 minus 2. And when we're counting the atoms first, we're going to say, well, in this chemical formula, I have carbon and I have oxygen. Carbon, there's only one of them. Oxygen, there's 3 of them in the chemical formula. Then I look at the group number for each of the atoms. Carbon lives in 4A. Oxygen lives in 6A. That means that each carbon atom is going to contribute 4 electrons. In this case, we have only one. And each oxygen atom is going to contribute 6 electrons. So when we multiply, we find that carbon overall is contributing 4 electrons. And when oxygen contributes electrons, there's 18 electrons. So that totals 22 electrons. But I want to specify something. When it comes to polyatomic ions, because they have an overall charge, that is also included in the overall count of electrons. Since this polyatomic ion has a negative charge, and since electrons are negative, we're going to add the value of the charge in the form of electrons. So we're going to add to the 22 that come from the atoms 2 electrons specifically, because the charge of this polyatomic ion is 2. So this is 24 electrons total. It's what carbonate has available for bonding to build this Lewis structure. Just to give you an example, let's say that we have ammonium to build, which we know it has a charge of +1. If I do the count, nitrogen, I have 1, hydrogen, I have 4, nitrogen contributes 5 electrons, but hydrogen contributes 1 electron. So at first, my count says that in this molecule, there's 9 electrons to build that Lewis structure. But since ammonium is +1, what I'm going to do is subtract 1 electron. So in ammonium, there's actually 8 electrons available for bonding. Remember that here I am subtracting electrons because this charge is positive. In this case, I'm adding electrons because this charge is negative. And every time you have a polyatomic ion, you need to remember, if it's positive in the polyatomic ion, I'm going to subtract that charge number from my total count of electrons. And in the case of negative ions, in polyatomic ions, I'm going to add that quantity to my valence electrons count. Let's continue. When I look at carbon versus oxygen in terms of their electronegativity, I go back to my table. I can see carbon is less electronegative than oxygen. So that means that when I'm building this structure, carbon is my central atom. And then I'm going to write the oxygens around it. Out of my 24 electrons, this skeletal structure already used 2, 4, 6. Minus 6 electrons. There's 18 electrons still available for bonding. I need to fill in the octets of the outside atoms first. Each one of those oxygens needs 6 electrons to fill their octet. So that means that these 18 electrons are already utilized by all of the oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I already used my 18 electrons. So there's no more electrons available for bonding. Out of all of my atoms, every single oxygen have 8 electrons around them, but carbon doesn't. So you may choose any of those 3 oxygens. You can select the one to the left, the one on the top, the one on the right. Only one of them needs to share in electrons with carbon. I'm going to choose the one on the left, but you could have chose any of the other ones. So what I'm going to do is that I'm going to erase 2 electrons and then share them in with carbon. Now, all of the atoms in my molecule have 8 electrons. When it comes to formal charge, I'm going to just highlight the oxygens in different colors so we can observe the formal charge for them when we do the equations and we can distinguish them. So I'm going to color this oxygen as blue, this oxygen as red, this oxygen as yellow, and then I have the carbon atom. Let's determine now the formal charge for every atom in this molecule. Let's start with carbon. Using the equation for formal charge, I write the number of valence electrons in carbon. From its group number, I know is 4. I'm going to subtract that from the number of bonds. Carbon has 4 bonds. I'm going to then subtract the number of lone pair electrons. Carbon doesn't have any dots around itself, so that means that the value is 0. When I do 4 minus 4 minus 0, that means that the formal charge for carbon is 0. So the formal charge for this carbon is 0. Let me now write the oxygens and color them. So it's easier to distinguish. So this is the oxygen in blue, the oxygen in red, and lastly, the oxygen in yellow. Let's now do the equation for the oxygen in blue. When it comes to the oxygen in blue, oxygen, because it lives in group 6A, it has 6 valence electrons. When it comes to the number of bonds, it has 2 bonds. So we're going to subtract those 2 bonds. When it comes to how many number of lone pair electrons are around that oxygen in blue, we have 1, 2, 3, 4, minus 4. So that means overall that when I take 6 minus 2 minus 4, the formal charge for that oxygen in blue is also 0. Let's now do the one for red and the one in yellow, which they're going to have the same equation. So I just have to copy my work 2 times. Let's do the one in red, and that will take care of the yellow also because they have the same bonding and number of lone pairs. So the one in red, oxygen has 6 valence electrons because of its group number. Then we're going to subtract from it the number of bonds. Oxygen only has 1. Then we're going to subtract from that the number of dots. Around the oxygen, we have 1, 2, 3, 4, 5, 6. Minus 6. So that means that when we subtract 6 from 1, that's 5. 5 minus 6, that is -1. That same work can be utilized for the oxygen in yellow in this Lewis structure. So it's 6 minus 1 minus 6, which that equals -1, which means that each of those oxygens on carbonate have a formal charge of -1. And if we consider that this molecule overall has a charge of -2 is because of the formal charge of each of the oxygens in the Lewis structure.